In this video, we want to discuss the difference between Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). Here in this example, we have a couple of laptops, and let's say they want to communicate using the TCP protocol. To set up a TCP session, there's what we call a three-way handshake, and essentially this is a three-stage message exchange that happens in order to set up a TCP connection. Let's say laptop 1 wants to start a session with laptop 2. Laptop 1 will first send a synchronization message or a SYN message to laptop 2. This is basically to request the beginning of a TCP session. Laptop 2 is going to acknowledge that it has received the message from laptop 1, and if it agrees to start a TCP session with laptop 1, it will send back a SYNAC message. In other words, a synchronization acknowledgement message. When laptop 1 receives this SYNAC message, it is going to conclude the three-way handshake by sending a final ACK message, acknowledging that the TCP three-way handshake is completed. So we have SYN, SYNAC, and ACK, which completes the TCP handshake. TCP is considered to be a connection-oriented protocol because of the way this connection is set up. When we talk about UDP, this is considered to be a connectionless protocol. And what this implies is that it doesn't require a session to be set up as TCP does in order to communicate. So how does TCP compare to UDP? Well, with TCP, when we send information, the receipt of that information is going to be acknowledged. So if we send 3 segments over from laptop 1 to laptop 2, laptop 2 is going to respond, essentially saying, okay, I received segment 1, 2, and 3, and I'm ready for segment 4. This means we have the assurance that everything we are sending is getting to the intended destination. With UDP, there's no mechanism like this in place. UDP will send information as a best effort, and we basically just hope it gets there. We have no acknowledgement or no evidence whatsoever that the data actually made it to the intended destination. Both of these protocols are, however, transported via an IP packet. The IP packet will have a source and destination IP address inside either IP version 4 or IP version 6, and the packet will contain either a TCP or UDP segment containing our actual data. So think of IP being like this truck, and we have a couple of payloads, a TCP payload and a UDP payload. Because of the way these protocols operate, we consider TCP to be a reliable protocol because it is connection-oriented, and we consider UDP to be an unreliable protocol because we don't have any acknowledgements when we use that method. That begs the question, why would we ever want to use an unreliable protocol? Well, there are lots of reasons for this, but I'll mention just the most prominent. TCP is slower than UDP. The reason for UDP's superior speed over TCP is that its non-existent acknowledgement supports a continuous packet stream. Since TCP connection always acknowledges a set of packets, whether or not the connection is totally reliable, a retransmission must occur for every negative acknowledgement where a data packet has been lost. But because UDP, on the other hand, avoids the unnecessary overheads of TCP transport, it's incredibly efficient in terms of bandwidth and much less demanding of poor performing networks as well. The flow controls from TCP, although dependable, are unable to recover missing data fast enough to be useful in real-time video communications. And while data integrity is important, it has to be balanced with speed to ensure the pace of communication remains unhindered. This is especially so if we have things that are sensitive to latency. When we say latency, we mean any sort of delay before a transfer of data begins following an instruction for its transfer. In the voice-over realm, for instance, using apps like Skype or live meeting apps like Zoom, we have this exact case where we are extremely latency sensitive. We don't want our voice packets waiting for acknowledgement that gives them higher latency. So we send packets over UDP instead when we're using voice-over IP. Even if we did drop a voice packet and we found out that we need to retransmit that, if we did that through TCP, it's going to sound very strange to have those voice packets arrive out of order. So that's a specific case where UDP is preferred. Let's look at this from the perspective of a client and a web server. We can see our client IP address of 10.1.1.1 and the web server address at 172.16.1.2. When the client sends a packet to the server, we see that the packet is labeled with a source and destination IP address. And we also have source and destination port numbers as well. If we're sending this traffic to a web server, this is going to be TCP traffic, and it will use the well-known port of TCP port 80. Later in this course, we'll look at other well-known ports that you will need to know about. But for now, just know that web traffic using the HTTP protocol uses port 80 commonly. Also notice that the source port for the packet going from the client to the server is 49,158. We also have what are called dynamic private ports, and those range from 49,152 all the way through 65,535. These are picked somewhat at random so that the web server has a port to return the traffic to. So in this case, the traffic returning from the web server to the client is going to use destination port 49,158, which it was informed to use in the original packet sent from the client. So now that you understand some of the differences in TCP versus UDP, in our subsequent videos, we're going to take a look at some other well-known ports that we use for many other popular protocols.